Hello, algebra students. We have one last topic to finish up when we're working with our radicals. We've already simplified radicals, multiplied, distributed, divided. Today we're going to be adding and subtracting. And for that, we'll need to use all of our simplifying skills that we've worked on so that we can get each of the parts that are being added and subtracted simplified to decide if they're like terms. If the radical parts match, then we can combine them just like we would combine things with variables. But if the radicals don't match, then they can't be added together. So far, we haven't had any problems where the radicals did match. And today, sometimes we'll have problems where parts of them match, but not all of the terms. So you have to be careful here. In this first example, the rad 6 is simplified. Hopefully by now you're comfortable knowing that if I split that 6 into a 2 and a 3, there's no pairs. That's not going to simplify. I don't even need to bother doing anything with rad 6. However, 54 can be simplified. That'll be a 9 times 6. The 9 is going to be a 3 and a 3, so there's a pair. The 6, okay, we just did 6 in the last part of this. 2 times 3, that doesn't do anything. So it's going to stay as a 6 right there. I do want to point out that what we get from simplifying in that first part of the problem we can't circle like the 6 in the leftover part of the 54 with the 6 in the other part. It's adding and subtracting is a totally different thing than just multiplying. So when I simplified the beginning of this problem, I had the -3 that was out in front. We have a pair of 3's that are going to break out, and I have a rad 6 that's left over. Then I had a 3, rad 6. The only thing I'd want to do before I try to add or subtract this is we can put this -3 times 3 to be a -9, rad 6. When you're doing this kind of problem, I want you to consider those rad 6's to be almost like variables. So we're really looking at like -9x minus 3x. How many x's do I have? Now I'm going to say -9 rad 6 minus 3 rad 6. How many of those rad 6's do I have? So you can certainly do keep, change here if you want to, but these are like terms. So -9 plus a -3 is going to be a -12 of those like terms, which happen to be rad 6's. In the second problem, this time both parts are going to simplify. So the 20, I can make that into a 4 and a 5, and the 4 will be, there's a pair of 2's. In the 45, I've got a 9 and a 5, pair of 3's. And again, the 5's don't circle, they don't match. I can't cross that line in the middle there. So I had the -3 in front of the rad 20. Then I broke out the 2, and all I had left over was just this rad 5. In the 3 rad 45, I had the 3 that was out there, and then I also broke out this 3. And I have this leftover rad 5. So this is really a -6 rad 5 plus 9 rad 5. So these are both rad 5's. They match. They're like terms. So now I just have -6 of those things plus 9 of those same things would give me +3 of those like terms, which is just a rad 5. Okay, if you didn't start taking notes on that first slide, I would suggest that you do start writing some of these down. The negative that's in front of the rad 27, we know that's really just a -1 times rad 27. 27, some people are comfortable just saying 3, 3, 3. You can also do 3 times 9, and then that splits up. So there's a pair. So I had the -1, and I had a 3 that broke out, and I have a 3 that's left over. That part doesn't change yet. So this is really, honestly, many of you, I'm sure, would just rather, instead of writing what I just wrote, go right to a -3, rad 3. And again, like terms, they're both red threes. So I have -3 of those things plus 2 of those things give me -1 of those things, or just a negative. If you want to put a 1 right there, there's nothing wrong with that. You just don't have to write it that way. In the second problem, there's actually no simplifying needed. I do want to make sure that we see that this is really, again, just like in the last problem, really a -1 times rad 3. And I would even do a keep, change and say that's a -2 rad 3. They're both rad 3s. So I have -1 of them plus -2 of them gives me -3 of those rad 3s. We just did another problem with 20 and 45, right? We're trying to keep it so that we're getting those like terms. So 20 would be a 4 and a 5, and there's a pair of 2s. The 45 is going to be a 9 and a 5, and there's a pair of 3s. So I have the 2 that was on the outside of the rad 20, and then the 2 that breaks out, rad 5 left over. I had the 3 that was on the outside of the rad 45, the 3 that breaks out, left over rad 5. So I have 4 rad 5 plus 9 rad 5. It's going to give me 13 rad 5. So here's another rad 27. And we just did a problem where I had a 3 times a 9 or a 9 times 3, and then I broke that down. If you want to do this, you certainly can. Just keep in mind, these are just square roots right now. I only need pairs. I can't circle all 3 of those 3s that I just wrote just because they all match. I only need pairs here. So I had, oh, there's my pair that matches. I guess I don't need this line to be quite so long. I had a -3 rad 3 from the first term. Then I had a 3 that was outside the 27, a 3 that breaks out of the 27, that's that one right there. And then I've got my leftover rad 3. And again, both of them are rad 3s, they match. So -3 plus 9, when I combine those like terms, I would get 6 rad 3. We will have some problems where it's more than just 2 terms that I'm trying to simplify and combine. So it would be very tempting to just grab those rad 24s and say I have -2 of them and -3 of them, that's -5 rad 24. Rad 24 isn't actually simplified. And we want to see if it'll match with the rad 8 once that one's also simplified. So let's break down that 24. Let's go with a 4 and a 6, because the 4 will be 2 and a 2. When I split up that 6, I get a 2 and a 3, and nothing pairs up with that. So I have -2 on the outside, the 2 that breaks out, and then a rad 6. This 24 is going to be the exact same thing. 4 times 6, you don't necessarily need to redo this tree. I would have the subtracting 3 or -3 that was outside, the 2 that broke out right there, and then the rad 6 that's left over. Here, I have the subtracting 3, I have a 2 that broke out, and I have a rad 2 that's left over. So simplifying each part here, I've got a -4 rad 6 minus 6 rad 6 minus 6 rad 2. Now I said we can only combine them if they match. These match because they're both rad 6s. So I have -4 of those rad 6s, and -6 of those rad 6s would give me -10 of those rad 6s minus 6 rad 2. They just stay like that. They don't combine. They can't do anything else with it. We actually have had problems that look like this at the end already when we were doing distribution. You just weren't looking to combine them at that point. In the second problem on this slide, The 24, I know that we just did that twice over here. We'll have 4 and 6, 2 and 2. I'm not going to bother to break down the rad 6. The 54, we've also broken down already today. 9 times 6, 3 times 3. And again, I'm not going to bother to break down that 6 because it doesn't break down at all. So I had the 2 that was outside the rad 24, the 2 that breaks out, rad 6 left over. That middle term, I didn't do anything with it. It's just going to stay as a 3 rad 6. Then I've got the subtracting 2 or negative 2, the 3 that breaks out, the 6 that's left over. So 4 rad 6 plus 3 rad 6 minus 6 rad 6. So 4 of those rad 6s plus 3 of them, it gives me 7. And then subtract 6 of those 7 rad 6s, I would have 1 rad 6, right? So 4 plus 3 was 7. 7 minus 6 is just going to be 1 rad 6. In these last two problems, we've got 4 terms in each of these. So, again, not a whole lot of creativity because we're trying to keep our numbers rather small and still have common parts that'll work here. So 54 is going to be 9 and 6. I'm not going to bother trying to break down the 6. The 18, knowing that I've got a rad 6 already left over, I could look at, how I could split that up, and I know I could use a 3 and a 6, but then I do have another pair. So instead of that, I'm going to go with the 9 and 2. There's that pair. So the leftover parts here don't match. That's okay. The rad 2 doesn't simplify. 24 we've just done a whole bunch of times. 4 times 6, 2 times 2. Okay, so I had the negative 3 on the outside, broke a 3 out, rad 6 left over. Second term, I had the 2 on the outside, 3 broke out, rad 2 left over. Then I had a negative, I'm going to put a 1 in front of that. Then I've got a subtracting 3, 2 breaks out, rad 6. So this is really negative 9 rad 6 plus 6 rad 2 minus 1 rad 2 minus 6 rad 6. So our rad 6s match. Negative 9 and negative 6 would be negative 15 of those rad 6s. And then I've got 6 rad 2 minus 1 rad 2 would be 5 rad 2. And for my last problem, the 45, 9 and 5, there's a pair. The 20, 4 times 5, there's a pair. The rad 5 just stays. The 20, again, 4 times 5, there's my pair. At this point, I'm going to show you, instead of writing everything exactly like I did in the last problem, for myself, I take this 3 times this 3 that breaks out, and I'm okay saying that that's just a 9 rad 5. If that makes sense to you, and you can see the rest of this and say, well, the negative 3 up here times this 2 that breaks out would give me a negative 6 rad 5. Then I had a plus 3 rad 5. And the 3 times, remember this is just a single 2 that'll break out. That would be 6 rad 5. So all of these had rad 5s. I actually wouldn't just add this going straight left to right either, because this is a negative 6 rad 5 right here and a positive 6 rad 5. Those are going to just take each other out. So 9 rad 5 plus 3 rad 5 would be 12 rad 5.